Pumping lemma for regular languages. Consider L be the regular language and there exists a constant n such that if z is any word in length, we can write z equal to uvw, where modulus of uv is less than or equal to n and modulus of v is greater than or equal to 1. Then you find uv power I w that also belongs to L for all values of I greater than or equal to 0. This is the lemma. This is the pumping lemma. That is, any string in the language can be divided into two parts, U, V, and W. All the strings you can divide it into three parts, U, V, and W. If UVW is belongs to the language L, then U V power I W also belongs to L for any value of I. That is the pumping lemma. This is used to prove, the pumping lemma is used to prove that some languages not regular. Here we are using the proof by contradiction technique. Here this is proof by the contradiction. That means first consider the given statement is true and proceed that after sometimes you will find will not get the correct answer, so that this is wrong. We are going to prove this by proof by contradiction method. Else we can see the example for this one. Show that L equal to 0 power n, 1 power n, where n is greater than or equal to 1 is not regular language. Here it is given that L equal to 0 power n, 1 power n, right? So and you say some strings that belongs to this language, suppose I am considering n equal to 1, I can write the string equal to 0 1. I am considering that n equal to 1, then the string is 0 1, 0 number, n number of zeros and m number of ones, that is the equal number of zeros and ones. If number of 0 equal to 5, then number of 1 is also equal to 5. That's the meaning of this language. But here n equal to 1 means I'll get the string 0 1. If I am replacing n equal to 2, I'll get the string 0 0 1 1. Now I am going to prove that this is not a regular language. Actually, this is the context-free grammar language. So I'm going to prove that this is not regular by using the pumping lemma. According to pumping lemma, any string can be written as any. This is Z. Consider this is the string Z. Any string can be written as U V W. If U V W belongs to L, then U V power I W is also belongs to L. This is the lemma, pumping lemma, such that modulus of Z is always greater than or equal to N. Modulus of Z is always greater than or equal to N. These are some conditions. Modulus of V is greater than or equal to 1, at least V must contain only one symbol, and modulus of UV is less than or equal to N. It will not exceed N. These are the conditions for pumping lemma. Here I have taken Z equal to 0 0 1 1. I am going to prove this one. First take modulus of Z. My string is Z equal to 0 0 1 1. That is number of zeros equal to 2 and number of 1 equal to 2. That is Z equal to, I can write this as Z equal to 0 power 2 1 power 2. That is belonging to the language 0 power n 1 power n. Now I can split it into 0 0 1 1. This is my string. I can take my string as, I'll write this as, here I'll take, according to pumping lemma, every string can be splitted into three parts. I'll split this into three parts. Anything, any number of zeros and ones, I am considering this is U and this is V and this is equal to W. Any order you can take. What is U? U equal to 0, V equal to 0 and W equal to 1 1. If U, V, W, Z belongs to the particular language N, L, then according to pumping lemma, U, V power I, W also belongs to N. Now I am considering, I am taking I equal to 2. You may take I equal to 3 or I equal to 0 or anything. I am taking I equal to 2. If I take I equal to 2, what will be the answer? U V power 2 W. If I calculate U V power 2 W, what is the answer for this one? What is U? U is 0. What is V? V is 0. Then V square? V into V. So 0 into 0, 0, 0. What is W? W is 1, 1. I am just replacing V with V square because according to pumping lemma, U V power I W is also belonging to N. If you consider this one, how can you write this as 0 power 3, 1 power 2? Is it belongs to the given language? What's a given language? Our given language is 0 power n, 1 power n. If number of 0 is 3, the number of 1 must also be 3. But when you are calculating u v square w, you got 0 power 3, 1 power 2. This is not in your language. This is not belonging to our language. So if I am taking v equal to 0, this proof is wrong. I got the wrong answer. Now, I may take another case. I am considering, now I am going to change my dictation. What is my string? Same thing. Is it equal to 0011 only? I am taking US 00, BS1 and WS1. I am taking BS1. Previously, I was taken 0 as B. Now you calculate U B square W. Calculate U B square W. Then U is 00. B is 1. So what is V square? 1, 1. W is 1. So this is U V square W. According to pumping lemma, if U V W belongs to L, then U V square W also belongs to it. How can you represent this one? 0 square 1 power 3. Here 2 zeros and 3 ones. This is all not also belongs to the language L. If you take V equal to 0 or V is equal to 1, whatever be the things, you are not getting the correct syntax of the language L. Hence, we can say that this is not the regular language. If it is the regular language, U, V square W also belongs to 0 power n, 1 power n. Here it does not belong to 0 power n, 1 power n. Hence, by using pumping lemma, we prove that the language is not the regular language. Similarly, we can prove one more thing, one more example. Consider this example. Show that L equal to W, W power R, where W belongs to A comma B, the whole star is not a regular language. What is our pumping lemma? Pumping lemma state that any language is set, any language we can write is set such that you should take is set equal to any language, string belongs to the language, string belongs to the language, and if u v w belongs to L and u v power I w also belongs to L. This is the pumping lemma. We are going to prove that. For that, first consider the modulus of Z. Modulus of Z must be greater than or equal to n, and then find v is greater than or equal to 1 and uv is less than or equal to 1. The conditions are modulus of z is greater than or equal to n, modulus of v is less than or equal greater than or equal to 1, modulus of uv is less than or equal to n. You should check these conditions also. W power r, if you are taking one word belongs to A comma B, the whole star, combination of A and B. Then W power R means, suppose I am taking, I'll take one string such that is set equal to A power 2 B. We can write this as A power n, B power m, then W power R. W is A power n, B power m. I can write W power R as B power m, A power n. So clear to you? W power R. I'm going to prove that this is also not a regular language. How can I prove that? I'll take n equal to, for example, I'll take n equal to 2 and m equal to 1. What will be the string? Is set equal to A square, A power n. So A square, B power n, B. Then B, A square. This is my required string. I'm going to prove that this string is not a regular string. This string is not belonging to the language W power R. So first I'll take that. How can I write this one? Set equal to A, B, A. Fine. I'll split it into 3 parts. I'll take the first is U, this A, B as B, and this is W. Now take V square. I'll calculate the V square. What is U V square W? U V square W equal to U A V square, V into V. What is V into V? V is ABB. Okay, ABB is V square. So again ABB AA. This is the string u v square a. I'll write this one. How many a's are there? 1, 2, 3, 4, 5. So I can write this as a square, b square, b square, a power 3. This is the resultant string. To calculate this one, if number of a here is 2, then this also should be 2. Okay, b is okay. Number of b is 2 here and 2 here. But when you see this a, here number of a is 2 and number of a is 3 here. That is not in the given form. That does not belongs to L. I'll take it in another order. Consider another one is set combination is set equal to same thing a same string I have taken b a. Now I am considering this is U and this is B and this is W. So I'll find U V square W. You can find either V Q W or U V power 0 W. Anything can be taken. If you take this one, you'll write B, B square, then B into B, B into B, then A. What's the resultant string? A square, B power 3, A square. If you split this one, b power 3, can write this as a square b power 1 into b square or b square into b. Whenever you see this resultant thing, number of b's is, the power of b is not equal. Hence, this is not belonging to the language L. So, W power R is also not a regular language. Take the string from that one. For that string, find the value of UVW and UV power IW. If both are in the same format, then that is a regular language. But here we are getting the different things. So by proof by contradiction, the result is the contradictory one. Hence, we can say that this is not a regular language. This is all about the pumping lemma for the regular languages.